We start this lesson on 8.2, multiplying rational expressions, by doing a quick warm-up on factoring. So if you're good with factoring and finding the product, you could skip this section, but I'm going to go ahead and go over it as a quick review. So again, we are multiplying and dividing rational expressions today. First thing we're going to do is jump in. I see that I have a quadratic, and again, this is just a refresher. So if I factor using my reverse FOIL, we would have x times x, and we need factors of -8 that add up to -2. So that's going to be a -4 and a +2. So double check yourself. We've got our x squared, we've got a +2x, a -4x, and then last is our -8. All right, in this one, the first thing I was looking for was to reverse FOIL, but I actually always remember to go back to the basics of just GCF, and I can take out an x, and I'm left with x minus 5. And that is all I can do there. There's nothing left to factor. Same idea here. I'm going to go ahead and take out an x to the third, that's the GCF, and I'm left with x squared minus 9. And so when I go to double check that I've factored it completely, I see this x squared, and I see that I have two terms, and I have a difference of squares. So it's going to be very important to make sure that we factor correctly and thoroughly. So x to the third, two sets of parentheses, x times x, we want factors of -9 that add up to 0. So +3 and a -3. And again, you can go in and double check that to FOIL it. All right, the next couple problems are finding the product or multiplying. So in this one, we're just distributing. And so I would get 6x to the 6. So 6 times 1 is 6. We add our powers, we multiply the bases. And then 6 times -2 is -12. And we keep the x squared. On this one, I'm going to have to do a little more work. Some people use a box method to multiply this out. Some people stack it. For room's sake, I'm probably going to stack it. So the first thing I'm going to do is much like FOIL. I'm going to distribute the first term, but I have to do it 3 times. Okay? So everything's going to multiply by x. So 3x to the third minus 7x squared minus 1x. So everything here, all 3 terms got multiplied by x. Next, I'm going to come through and multiply everything by 5. So here we go. 5 times 3x squared is going to be a positive 15x squared. And so I'm just adding the like terms later, so I just figured I'd stack them up. And I have 5 times -7x, so that'd be a -35x. And then 5 times -1 is -5. So to add up all of my terms now, I have a 3x to the third. I have a positive 8x squared, a -36x, and a -5. And that's it, final answer. The next one is just distribution again. I have one term out front, so I'm distributing it to all 3 pieces here. And so when I do that, I take my 8 times 1, I get 8. Watch your powers, x to the third, y to the fifth. And then 8 times -4 is -32. X to the third, y to the third. So I'm taking my x's and combining them and just tacking on the y. And then 8 times 7, we get 56. And I keep the x squared, and I have a y to the third and a y, so y to the fourth. And that's it. That's our final answer. All right, so that was a quick review. In a prior lesson, an 8.1, we worked with inverse variation such that y equals 5 over x. And the expression on the right side of the equation is called a rational expression. Rational expression. So this part right here is considered a rational expression. A rational equation is a quotient of 2 polynomials. So if we're talking about equations, we're going to have a maybe a quotient, and it's going to be equal to something. Other examples of rational expressions, so expressions, would be x to the second minus 4. So we have a polynomial over another polynomial. So we have a quotient of polynomials here. And this is an expression because there's no equal sign, where a rational equation, we're going to see an equal sign in. So we're working with expressions today. Another example would be 10 over x squared minus 6, or x plus 3 over x minus 7. All right, well, the other day we reviewed fractions, our basic fractions from elementary school. And so real quick, let's go over the rule. Rational expressions are ratios of polynomials, meaning we have a fraction, okay? And you can simplify them the same way as you simplify fractions. Recall that to write a fraction in simplest form, you divide out the common factors in the numerator and denominator. Now, for most times, we would just go through and say, what do they have in common? The GCF here is 3, so we divide them both by 3. But to show you what we're going to get into, I'm going to rewrite this as 3 times 3. I'm going to rewrite this as 3 times 8. So 3 times 3 is 9, and 3 times 3 is 8. So I'm pulling out the GCF, and now I see that the 3 over 3 divides out to 1, and I'm left with 3 over 8. So we're going to be creating products by factoring the numerator, factoring the denominator, and then cancel out any common factors. All right, so let's get started. Again, this front page was just a review of content to help us. All right. So looking at the first one, we're starting off easy, and these are sometimes the ones that we forget are supposed to be the easy ones. So I have just a term divided by a term. That's it. So since there's no addition or subtraction, I can cancel top to bottom. I don't have to worry about factoring. 3 and 2 do not reduce, but x to the 7th and x to the 4th do. If I write out 7x is here and 4x is here, the first 4 would cancel out, and then I'd be left with 3 extras on the top. So I am going to go ahead and just cancel out these 4 on the bottom. It's really using the rule of 7 minus 4 is left over with 3. And we have 3 up top. So I'm left with 3x to the 3rd all over 2. All right. Now, it says identify x values for which the expression is undefined. There's a lot of times I would teach this where I would just teach the simplifying it, and then the second day we would go back and we would focus on the domain restrictions. But we're going to go ahead and focus on both of these today. So what is undefined? Well, it's undefined if it's a domain restriction. Remember, domain is what the x can be. So if we have a domain restriction, we're talking about what x can't be. And the domain restriction in our problems is coming from the denominator. The denominator cannot equal 0. Denominator, let me fix that, cannot be 0. I'm going to write out the word 0 so it'll look like an L. So basically you're going to set your denominator so it's not equal to 0, and then you're going to solve. And most of the time you're going to solve using the zero product property, which is something you learned with quadratics. And so just a quick reminder of the zero product property, if I have a times b equals 0, then we knew that either a equaled 0 or b had to equal 0. 0 times b would make it 0, or a times 0 would be 0. So if we have a product equal to 0, zero product property, then one of those pieces, one of those factors had to be 0. Now this told us what made it 0. We want to talk about what it can't be because it makes it 0. So domain restriction, I'm going to come back up here and highlight that. Domain restriction comes from the denominator. It comes from denominator before you cancel. Before you cancel. Or simplified. All right, that's really important to know. So the domain restriction comes from the denominator before it was canceled or simplified, meaning what could I put into the original problem that would cause an issue? So domain restriction always comes from the original problem, and we'll talk about that as we move forward. So in this problem, my domain restriction is really coming from the fact that, and I use DR, so domain restriction, I use a DR to sort of help save myself writing it out. Domain restriction comes from the fact that 2x to the 4th, the denominator, cannot equal 0. So I'm just going to solve it like an equation. 2 can't be 0, or divide by 2. So x to the 4th cannot be 0. And most of you would just say, okay, then x can't be 0. You know, we would take the 4th root, and the 4th root of 0 is 0. So in my domain restriction, I am stating that x cannot be 0. And my domain restriction is just as much a part of my answer as this 3x to the third over 2. So this is my reduced, cleaned up answer. My domain restriction is that x cannot equal 0. Okay, so maybe you don't have to write the DR for some teachers, but I'm looking for you to state, here's my domain restriction, and it's x cannot equal. That's what we want, cannot equal. But you do need to define the variable. Okay? Now, domain restrictions come into play different ways later with asymptotes and breaks and graphs, but that's another lesson. So I just want to bring that up, that you will come back and talk about domain restrictions and what they mean when you're graphing and looking for domains and ranges. All right, so if we look at this next problem, one of the biggest mistakes I get are people just knocking out these x's and maybe reducing something. The only time you can reduce or cross-cancel in fractions is if you have a product. You have numbers or quantities multiplied together. You cannot cancel over addition subtraction. I have 1, 2, 3 terms in the top, 3 terms in the bottom. If I can't take something out of all 3 terms, I can't take it out, but I can factor. And this is why factoring was so important. I'm going to factor the top equation to be x minus 3, x plus 1. And honestly, being able to factor quickly will make these problems work more efficiently for you, but it's also going to be really important to be accurate. All right, in the bottom, the factoring is x plus 4 and x plus 1. So you see that I've got my factoring done, and so I'm looking for any common factors, and the x plus 1 cancels with the x plus 1, so that's perfect. And that means my simplified form is x minus 3 over x minus 4. My domain restriction, what can't x equal? All right, my domain restriction is coming from my denominator. And so I'm not going to go back to the original denominator. I want it factored because in zero product property we would factor it. So I have x plus 4 times x plus 1. These are the two things that cannot multiply together and get 0. So what would make this 0? What would make x plus 4 0 if x was negative 4? And what would make x plus 1 0 if x was negative 1? And again, we're using prior knowledge. Now, normally if we solve, we would say we want x to be negative 4, we want x to be negative 1. But because we don't want the denominator to be 0, x cannot equal negative 4, x cannot equal negative 1. And just to show you real quick why. If I go back up to the original problem, I'm going to go ahead and use a calculator just to save a little time. I'll try to get that in there for you. And I go back and I put negative 4 in the denominator. So parentheses negative 4, close parentheses, square it, plus 5 times negative 4 plus 4. If I put that in the calculator, I get out 0. I can't take a number divided by 0. And I can put negative 4 up here. I can put whatever I want in here. I can have 0 in the numerator. I cannot have 0 in the denominator. So if I go back to my problem and I change this out with a negative 1, whoops, and here it is, and then I have the plus 4 at the end, again, I get out 0. So negative 4 and negative 1 are the two x values that will make this problem undefined. That's why your denominator cannot equal 0. We can't divide by 0. That is undefined. All right, so those are the tools you need for multiplication. So we're going to do a couple more examples to practice. This would be a great time to pause this recording and try these 3 problems on your own, and then come back and see how you did. I'm going to go ahead and go right through them, but again, you can always pause the recording. So 16 and 8 do reduce. 8 goes into 8 once, and it goes in here twice. And I'm going to knock out my x's, and I'm left with 9 up top. So I'm left with a 2x to the 9th. And that's it. Nothing in the denominator, but you could have it over 1. And I do need to consider my domain restriction. X cannot be 0. Okay, where did I get that domain restriction? That denominator, 8x squared, cannot equal 0. So divide both sides by 8. X squared cannot equal 0. Take the square root, and there you go. X cannot equal 0. One of the things that most people have a realization about pretty quickly is if it's just a number times a variable. It's just a variable in a product, no addition or subtraction, then the domain restriction is 0. Okay, looking at the next one, 3x plus 4 does not factor, so we're going to go ahead and leave that alone. 3x plus 4, there's no GCF there, and I do have to factor the bottom. It's going to take a little more effort because I have a coefficient of 3 on the x squared, so a is not 1. Now I'm going to cheat a little bit. Well, not really. I guess I'm thinking about it. If I want something to cancel, I know it's going to be a 3x and a 1x. And I was probably going to try putting a 3x plus 4 here, and this is really why we want to use pencil. Now, if this is 3x plus 4, well, 4 times negative 1 would give me back my negative 4. So I cheated just a little bit by saying, well, if it's going to cancel, it's got to be 3x plus 4. So this is what I tried first, instead of a 2 and a 2, or a 1 here and a 4 here. But I want to double check it, because maybe nothing cancels. There are problems like that. So this is a 3x, negative 3x, and that's a positive 4x, so I do get my 1 back. But again, don't assume there are problems that don't cancel. So now I do have a common term. You know, this is in parentheses here, and this cancels with this. And one of the common mistakes I get is that people say the answer is x minus 1. So if you have that, there is an issue. Where was the x minus 1? It was in the denominator. So when I say 3x plus 4 cancels with 3x plus 4, 3x plus 4 goes into itself one time, and it goes in here one time. So I have 1 over x minus 1. Now let's talk about a domain restriction. I'm going to come up here and set, well, I'm going to come back down here, I guess. I'm going to set my denominator, 3x plus 4 times x minus 1, and I don't want it to equal 0, but we're using the same concept here of zero product property. Now, this one I've got, x cannot be 1. 1 minus 1 is 0. This one I've got too, it's x cannot be negative 4/3. But if it doesn't come naturally to you, take this off to the side and make it 3x plus 4 cannot equal 0. That's why I'm getting the negative. I'm changing the sign by subtracting it. So I get 3x cannot equal negative 4, and then I'm dividing by 3. I find a lot of people sometimes get errors with this. They mess up a sign, they forget to divide properly. So sometimes it's worth just taking it to the side and solving for 0. It takes you a second, but it helps your brain. But my domain restriction is that x cannot be negative 4/3 or 1. You can put the word or in there, you can do the x cannot equal twice, or you can just list them like I did. Okay. Oh, it's so hard not to just cancel out the 6x squared with the 6x squared. But if I can't take that 6x squared from all 6 terms, then I can't cancel it out. So I'm going to have to factor. So you're going to have to put a little effort into this factoring. So you might do it on a piece of scratch paper, or again, do it with pencil. I'm going to go ahead with a 2x and a 3x. My only factors, well, they have to be both positive because they have to multiply to 2 and add up to positive. And then I'm going to go ahead and think about this a little bit. I need them to add up to 7. So I'm thinking about putting the 2 here and the 1 there, because 2x times 2 is 4, 1 times 3 is 3, and that adds up to my 7. All right, now I'm going to come into the denominator, and I'm going to guess that I'm probably going to use like a 3x or a 2x. So we'll put those down there, and then I have to work it out a little bit. Now this time I want one positive, one negative. So I'm going to do a little bit of trial and error, or guess and check. I'm going to go with the positive 2 and a minus 3. Again, this is something that you would have tried and worked out and double check yourself. So it might not work the first time. So there's my 6x squared. There's my negative 6. Or sorry, that's a negative 9 and a positive 4. So I want to double check that I got my negative 6, but I also need this to work. So negative 9, positive 4, there's my negative 5x. All right, now that I have it completely factored, I'm looking for something to cancel, and I'm canceling the 3x plus 2 and the 3x plus 2. So what's left over is 2x plus 1 over 2x minus 3. Now, I do need a domain restriction. What can't x equal? So my denominator, this comes from my denominator, 3x plus 2 times 2x minus 3 cannot be 0. All right, so if that cannot be 0, I have to look at this, and again, you might go off to the side like I did here, take 3x plus 2, set it to 0, and solve it, we would get that x cannot be a negative 2/3 or x cannot be a positive 3/2. And this again is an old skill that we used, but we're using it as a restriction rather than solving for 0 because we want the zeros. We want it not to be 0 because it's from the denominator. This is a concept that sometimes we don't see, and then when it clicks we realize, oh, that was really easy. We just take our denominator before we cancel anything, we set it to 0, and we solve it. But we're talking about a restriction. Now, if we want to talk about what the domain is, then the domain can be anything but negative 2/3 and 3/2. And there's other ways to write that with inequalities as well as writing it with interval notation. All right, we have a couple more examples here about reducing rational expressions, but sometimes we have to force them to work by factoring out a -1. So it's something that is a good skill to have and can be very useful if you're finding that you have the same factors but they're not quite the same signs. So we're going to go ahead and look at this first one, and some of you might look at this and say already that you notice that the 2x minus x squared, it's not in standard form. So the first thing, you don't have to do this, but the first thing I like to do is to rearrange it. So I have the negative x squared plus 2x all over x squared minus x minus 2. I think it helps our brain for factoring. Now the next thing I'm going to do is I'm going to take out the GCF. Now typically if my first term in the polynomial is a negative, I'm going to factor out that negative. So I'm going to take out a negative with the x, and that's going to change it to positive x and a negative 2. Now, maybe I didn't need to do that, but I'm looking at this as a positive x squared. So when I go to factor, I'm going to get a positive x minus 2 and a positive x plus 1. And that's how that piece factors. And so by taking out that negative, these are the same. If I hadn't taken out the negative, I would have had an x out here, and I would have had a negative x plus 2. So sometimes you'll realize that you might have to change the signs just by looking at it. And so if I hadn't taken out the negative, I would have seen that, look, I have an x and a 2 here, but they're the opposite signs. And both signs have to be the opposite. So by coming in and saying, okay, I better take out the negative, which changes and changes, now I can cancel the common factors. All right, so what we're left with here is a negative x over x plus 1. And again, the domain restriction comes from the original denominator before I factored. So I'm going to go ahead and set, or before I canceled, I'm going to set this up equal to 0. X cannot be 2. X cannot be negative 1. X cannot be 2 or negative 1. So again, we are relying on a lot of prior skills. We're really relying on factoring skills and using our zero product property to solve quadratics, and we're looking at them and using them a little bit differently. If you're good with those skills, this is very, very easy for you. All right, so we have a couple of problems here to practice. And so again, I'm going to go ahead and just start by rearranging that and make that a negative 2x plus 10, and down here is an x plus 5. So the first thing I realize is it's a positive x, and here I have a negative x. So I am going to want to go ahead and take out a negative 2, and what's left is x minus 5. And it's really important when you factor out a negative that both signs change. And then down here, I wrote it wrong. This, because I looked and I thought, well, that's not going to cancel. So I looked back at the original problem, and I realized that this was an x minus 5. So I was able to catch my mistake there. And so I keep my x minus 5. Now, maybe it wouldn't have canceled. I had written the problem wrong, and so I was questioning it. So these cancel out, and I'm left with just a negative 2. And then my domain restriction, I like to denote this is my domain restriction, is that x cannot equal positive 5. Because my denominator cannot equal 0. Okay, looking at this problem, it's in order, but I notice I have a negative out front, so I'm going to take out a negative x. And what's left is x minus 3. Again, don't forget to change those signs. It's going to take me a little bit of effort, but not too much to factor 2x and x. My only options are 3. and 1. And I know they both need to be negative because I need the same signs to get a positive 3, but they have to add up to negative 7. So you need to try these. I'm going to put the 1 here and the 3 here because that gives me a negative 6 and a negative 1, which gives me a negative 7. You can see I have a common factor here, and so that leaves me with a final answer of negative x over 2x minus 1 with a domain restriction of x cannot equal. Okay, so here we go. Again, you might do this off to the side, but we would add 1 and divide by 2. So x cannot equal a positive 1/2 or a positive 3. And that is my domain restriction. Okay, so we are moving on to one last step here. And so again, all of this is using prior skills and can be very easy for some of you, and for some of us who factoring did not come naturally, we didn't practice it enough, this is going to be harder for you because you're going to have to take time to figure this out. If your signs are wrong, that's a problem. And again, same thing with using the zero product property that came in play with solving quadratics. All right, if we turn to the back, we have something that looks a little different. The title of these notes, the title way back at the beginning said multiplying rational expressions, and we haven't multiplied anything yet. We've just been reducing fractions. And notice this title said multiplying dividing. I'm going to do a whole nother lesson on dividing, which is actually very simple because instead of dividing by a fraction, we multiply by the reciprocal. So we're going to use all of our skills again. It will be good practice when we do the next lesson in dividing. So now we're getting into multiplication. And so when I talk about this, you can see I have one fraction times another fraction. And with our fraction review, we remember that we can cross cancel. For some people, they're going to put all of this together and reduce. But because everything is a product here, 2 times x to the 4th times y times a 15 times x, all of these are products. Everything is already set that I can cancel. So I can cross cancel the 2 and the 8 to be a 1 and a 4, and I can cross cancel the 3 goes into 3 once, and 3 goes into 15 5 times. So number-wise, I'm left with a 5 over a 4. And then we can look for our x's. Now up here I have 4 of them. Down here I have x to the 2nd and 3rd, so I have 5. So if I take out 4, that takes out all of these and leaves me 1x in the bottom. And I just lied because I have x squared up here. Okay, so maybe, let me recalculate here. Maybe I should have cleaned it up. And that's exactly what I talked about in a prior lesson. Sometimes we miss something. So in the top I have x to the 6th. And in the bottom I have x to the 5th. All right, so that knocks that out and leaves me the 1 up top. I had missed that one. All right, the y's in the top is just y to the 5th. And I only have y squared in the bottom. So that knocks that out and leaves me y to the 3rd on top. So my only piece in the denominator is a 4. Now, one of the things that I am doing in this is it says assume that all expressions are defined. Okay, so if I asked you for a domain restriction, in this problem I'm not, but if I did, x could not be 0 and y could not be 0 because both x and y are inputs here, and nothing in my denominator can wipe it out to 0. So 3 times 0 would be a problem, 8 times 0 would be a problem. So this was what I was looking for. Anytime you have two variables, there are more things to consider in your domain restrictions. All right, so I have multiplication here. It is the same as me rewriting this numerator as x plus 2 times x plus 4, because that's how we multiply fractions. We multiply across the tops. Now, this is already pre-factored, if you will. I don't want to multiply this out. I want to keep the pieces. Now down here, I do need to factor this, and this factors as a 3 and then x plus 4 times, and this factors as a difference of squares, x plus 2, x minus 2. So you can see that each piece is factoring. So again, if you want to keep it separate, there's your top 2 pieces, here's your bottom 2, but anytime I have a fraction times a fraction, I can cross cancel, or I can build it as one fraction. So I am able to cancel this x plus 4 with that one, and an x plus 2 with an x plus 2. So we had an example like this. The top is 1, and the bottom is 3 times x minus 2. Now, the textbook that we use for my class leaves the answers like this. And I think that's good so you can see the pieces. But the final answers that I require on worksheets, tests, quizzes is for you to go ahead and go back and redistribute. And that would be the 3x minus 6 is my new denominator cleaned up. So this is it. And again, it's saying that the expressions are defined, but just to practice that domain restriction, I know it adds a little time onto our lesson, but just to practice it, we have to look at all the pieces of the denominator before it was canceled. Well, 3 will never be 0. It's a constant. It will always be 3. But x plus 4 could be 0 if x was negative 4. X plus 2 could be 0 if x was negative 2. And x minus 2 could be 0 if x was positive 2. Which also could be written as negative 4 plus or minus 2. Either way works. But that is my final answer with the domain restriction for extra practice. All right, so here we have some check it outs. And again, this is something that you could pause the video at this point and give it a try. And again, they're assuming that they're all defined, but I'm going to go ahead and go over the domain restriction for some practice. All right, in this problem, it's up to you. You saw that I made an error, so maybe I should just take a note from my own page here, and let's just clean it up. This would be 20x to the 8th over, we can do 15 times 2 is 30, x to the 5th. And don't forget that that is a 1 there, and that's why I have 5 of them in the bottom and 8 up top. Okay, the 20 and 30 are going to reduce, so I'm left with 2 over 3. They would have a common GCF of 10. And then there are going to be these canceling out and leaving me x to the 3rd on top. Domain restriction, x cannot be 0. 15's fine, 2's fine, but 2 times 0 is not. 0 to the 4th is not okay. So if x is 0, that causes our denominators to be undefined. Notice the numerator has no stipulations on it. It's the denominator that cannot be 0. All right, so we have some work to do. We have a fraction times a fraction. So your first step to these is to factor all the pieces. Don't jump into anything, just factor everything, because none of these can be reduced. So take out the 10 in the top, and I'm left with x minus 4. All right, in the bottom, each piece, just go through each like it's so you're really factoring 1, 2, 3, 4 things. So I took out the top, there's nothing left. The bottom factors to be x minus 4, x minus 2, times the top, nothing to factor. All right, maybe you put it in parentheses, but you don't have to. You put a 1 out here. And the bottom, we have a GCF of 5, and then you're left with x plus 3. Okay, now again, because I have multiplication, I can cross cancel. But I can also cancel any top to any bottom. So these cancel, which is great. But there's one more thing that cancels that people forget about. We're so involved with these pieces, these binomials, sometimes we forget the 10 and the 5 reduce just like any other fraction. So that goes in here once and it goes in here twice. So the top I'm left with just a 2, and the bottom I'm left with just x minus 2. So that canceled out very nicely. All right, so now that I have that, my final answer, let's talk about a domain restriction. Again, we don't have to because it's telling us it's already been defined, but we're going to define it anyway. So in this piece, x minus 4 can't be 0, so x cannot be 4, x cannot be positive 2. 5 will always be a 5, okay, so that's not a domain restriction. There's no variable in that piece. But x plus 3 could be a 0 if x was a negative 3. And there you have it. So our next step would be to do a lesson on dividing rational expressions, but we will use the same rules. Okay, I hope this helps and you have a good memory of factoring and zero product property to help you.